EB solution for packaging and printing. First, let's briefly introduce electron beam curing. EB is short for electron beam. An electron beam is a beam composed of electrons. We have also been exposed to electron beams in our lives, such as the old CRT TV, which receives high voltage through an electron gun, and then draws electrons out and hits the screen to form an image. The principle of electron beam curing equipment is similar. The electron gun of the accelerator emits electrons, which are accelerated by the ultra-high voltage electric field inside it until the electrons approach the speed of light, pass through the metal foil window and hit our processing area, and carry out a series of radiation chemical reactions. EBC focuses on the manufacture of low-energy electron accelerators for curing. The application of electron beam started earlier in Europe and America. In the 1960s, Ford Motor Company first applied it to automotive dashboard and wheel hubs. Because it is healthy and eco-friendly with no odor. Automotive dashboard are exposed to the sun, which requires high yellowing resistance. In the 1970s, a beam was applied to the aviation industry, such as the curing of aviation composite materials, fuel tanks of aircraft, components and parts of the wings. In the 1980s, EB curing was introduced to the civil field for the curing of food packaging and pressure-sensitive adhesive tape. Tetra Pak utilized EB for sterilization and surface coating curing. 3M applied a beam to prepare high-performance adhesive tape. Generally, we divide the application of low-energy beam into three areas. The first one is surface curing. EB can cure the surface varnish, coating, ink, and adhesive on the surface of furniture board, food packaging, metal packaging. The second one is cross-linking, modification, and grafting. For instance, the solar photovoltaic film, after a beam irradiation, the cross-linking degree is improved and the outdoor service life is prolonged. After a beam treatment, the performance and life of automotive tire cord are improved. The third one is irradiation sterilization, which is widely used in filling bottle beverage sterilization, grains, poultries, and egg sterilization, exhaust gas degradation, wastewater treatment. Generally speaking, e-beam is a very widely used and basic common technology. EBC focuses on the research in the field of electron beam curing. The principle of electron beam curing. Why does the coating change from liquid to solid after electron beam irradiation? This is a cross-subject of nuclear physics, radiation, and reaction chemistry, mainly because electrons are bombarded on the surface of materials after being driven by high voltage. For example, if we play billiards, the white ball is equivalent to electrons energized by high pressure, which bombards the surface of the material, causing a chain reaction of some columns, producing a lot of secondary electrons, and promoting the cross-linking of some resins or monomers nearby. Breaking the chemical bond of the resin itself forms free radicals, which will reprecipitate and assemble, and individual small molecules will be connected into large groups. Macroscopically, it is the process from liquid to solid. When it comes to free radicals, people naturally think of UV curing, which is also realized through the reaction of free radicals. EB and UV have many similarities, both of which belong to radiation curing and precipitation through free radicals. The big difference is the difference in energy. EB electrons have mass, and its kinetic energy is much larger than that of UV photons. Many bonds that UV photons can't open can be opened by EB electrons. Moreover, EB's formula can be completely without adding initiator. In UV, initiator is a thing that people love and hate. Without it, the polymerization of UV can't be completed. Adding too much will cause a lot of post-curing problems, including yellowing, migration of initiator, and odor. At the same time, EB is a particle, which ignores the color and can penetrate the solid color coating. Moreover, EB curing has no temperature rise and is suitable for heat-sensitive substrates. Most importantly, its reaction is very thorough and its surface is very orderly and dense, thus giving the product very high physical and chemical properties. Theoretically, all chemical bonds, carbon-carbon single bonds, and carbon-carbon double bonds can be broken and then combined by EB. Due to the high energy of EB, all polymerization reactions can be completed. The experimental results show that the conversion rate can reach more than 99%. Because the reaction is complete, the surface of EB coating is very dense. The application of EB in packaging is mainly for flexible packaging, labels, and wrapping paper. EB cures the ink, coating, and adhesive. These are high molecular polymers, which can be polymerized by EB. Below, a systematic introduction will be made in combination with different scenes. When printing, using electron beam to cure ink is applied in European and American printing plants, such as Comexi and Uteco, which all have flexographic machines and offset presses. With EB curing, it can achieve high speed and very good printing effect. EB varnish curing, for example, cooperate with HP's Indigo. The traditional printing is to print inside and then to compound, as shown in the structural diagram on the left. In some enterprises in Europe and America, surface varnish curing is used to directly replace thewtermost film to obtain better surface effect. The traditional film-coated products have a high gloss of about 80 degrees. If the EB coating is used, it can make it very bright and have a high gloss, which can reach a gloss of more than 90 degrees. The traditional matte finish is achieved by covering the matte film, but the matte finish is not high, only a dozen or 20 degrees. Through a special process, EB can achieve very low gloss, 5 gloss, and soft touch. At the same time, the products cured by EB are excellent in scratch resistance, acid and alkali resistance, stain resistance, and aging resistance. In Europe, America, and developed countries, EB can achieve food-grade contact surface and can pass the FDA 21 certification. The main reason is that it reacts completely, does not need initiator, does not need any chemical components to participate in the reaction. The formula composition can be very simple. The polymerization reaction can be initiated directly by electron beam. Because EB has good penetrability, it can also make the effect of C-squared process, special laser, and fixed point coating. Most importantly, these special effects can be in direct contact with food. In addition, there are two advantages that need to be discussed together with digital printing. EB does not need to be maturated, so the delivery is very fast. Matching with digital printing, minute delivery can be achieved. The advantages of digital printing can be brought into full play. The other is the surface printing of single material, which reduces the use of plastic. Why is EB and Indigo so well matched? Indigo ink is electronic ink, which is a thermosetting resin. When the temperature is high, the ink will melt. Electron beam can effectively enhance the cross-linking of thermoplastic resin. When the surface is polished, the electron beam will penetrate each varnish layer of OPP and act on indigo ink to enhance the cross-linking of ink. The traditional resin and monomer are linear and not connected together. When the temperature is too high, they will move. Electron beams cross-link them with each other, forming a network-like three-dimensional structure, and the temperature resistance will be greatly improved. These are some tests that we have done. We use very strict heat sealing conditions and serrated handheld heat sealing machine to remove the pressure. It can be clearly seen that after EB irradiation, its temperature resistance has improved a lot. If we use a flat-headed perm to test, the temperature resistance effect is better because there is no tearing effect. The heat sealing temperature can be 190 to 200 degrees, and the ink will not melt within 3 seconds. It can be seen that EB and Indigo can cooperate perfectly. Some customers in Europe and the US will use EB for post-curing after purchasing Indigo. Besides printing and varnish curing, we are also doing electron beam recombination. The traditional composite bag has a 3-layer structure. The bottom PE is used for heat sealing, and the surface layer is a printed layer. Solvent-free composite or other composite methods will have some defects, such as the need for maturating time. EB composite does not need to be maturated. Moreover, we have tested that the peeling force after composite can reach 4.7 newtons, which can meet most application scenarios. EB compounding has many unique advantages. The first is stability. Solvent-free compounding, poor rubber mixing, uneven will lead to the problem of random drying, random drying appears in the cutting place, this bag may be a bad product. There is no such problem in EB compounding. As long as the glue is coated and EB is irradiated, a better compounding effect can be achieved. The second is fast delivery, which is also the trend in the past 2 years. The third is multi-layer one-time curing, and even 4-layer one-time curing can be realized. As long as the voltage and energy of EB selection are enough, it can be realized. The adhesive on the label is actually a kind of pressure-sensitive adhesive. A special application of EB in the label field is curing and cross-linking the adhesive on the label. 3M is a big technology producer in EB application. The adhesive tape of 3M, such as the adhesive tape of automobile engine compartment, is actually cured and cross-linked with EB. The environment of automobile engine compartment is harsh, which requires high temperature resistance and solvent resistance, good peeling coefficient, and strong cohesion. The label of chemical packaging needs solvent resistance and outdoor label needs weather resisting. Some of the stickers that children like needs to be in contact with human skin can avoid the problem of allergy by curing with EB. EBC focuses on EB curing. The early development direction was mainly in furniture board. After years of efforts, the application in this field was relatively successful and mature. Since 2023, the technology of flexible package and roll-to-roll has been popularized. At present, there are 3 types of equipment. The first is the experimental machine, the second is the roll-to-roll equipment used in packaging, and the other is the equipment applied to rigid sheets such as wood, glass, and iron sheets. We have a complete test platform in China, experimental machines developed in the laboratory, and small-scale pilot verification equipment including plates, coils, and mass production equipment for plates, which can help customers do customized development and avoid technical risks in research and development to the maximum extent. In addition to perfect hardware facilities, there is also a top professional R&D team in China, led by 2 doctors from the Institute of Physics of Chinese Academy of Sciences, and equipped with a chemical material development team, which can independently help customers make customized solutions, including process development. Be able to solve the customer's needs in one stop. This is a furniture board made by EB equipment, which has very high color saturation and excellent physical and chemical properties. This is the case of EBC's customers, including Sofia, Gujia, and China First Line customized furniture brands, who are already using furniture plates made by EBC's equipment, and they are also vigorously promoting them. If you have a plan to decorate, I suggest you go to the stores of these brands and personally feel the charm of EB electron beam plates. This is an application in a harsh environment. On the left is a semi-outdoor ancestral hall for printing, and on the right is an outdoor engineering project done in Wuxi. It has been 4 years, and the white door head has been weathered, the color has not changed. We have tested in the laboratory and can achieve 10 years without discoloration. This is an installed picture of our equipment for making decorative membrane materials. This equipment is an outcome of the cooperation between EBC and HP, EB varnish curing plus indigo digital printing. In order to be worthy of indigo in appearance, we have also made some industrialized designs. If you are interested in EB technology, you can contact us, and we will continue to explore the application of EB. If you have any special application needs, you can also contact us to discuss, and we will explore more EB application fields together. I believe that in the next 3 to 5 years, people will hear more about EB's name and see more about EB's products. Thank you all.